Hello everyone, and welcome to today's Energy Storage News webinar with JinkoSolar, where we'll be discussing the latest in technologies and thinking on the topic of utility-scale battery storage safety. Cumulative installations of non-pumped hydro energy storage are expected to far exceed 1 terawatt-hour globally by 2030, according to recent analysis from Bloomberg NEF and DNV. Bloomberg NEF has predicted 1.877 terawatt hours by the end of the decade, and DNV has forecast 1.6 terawatt hours will have been deployed by that time. And as of the end of 2021, Bloomberg NEF had found there were 27 gigawatts and 57 gigawatt hours of storage in operation in total worldwide, which, to be fair, felt like a lot at the time. But anyway, that's a huge amount of new storage set to come online. And in Bloomberg NEF's case, the forecasts have consistently been revised upwards over the past couple of years. The bulk of that capacity is expected to be provided by utility-scale energy storage. And for it to happen successfully, every stakeholder, from investors and developers to regulators, governments, and of course the public, need to have confidence that the equipment is safe and is being used in a safe manner. There is a lot of great work going on from people in the industry at all levels of system design, integration, installation, and operation. Today's battery storage systems have more layers of advanced smart protection against risks that include thermal runaway, fire, and explosion than even some of their fairly recent predecessor systems. And certifications and standards such as UL 9540 and NFPA 855 ensure minimum levels of safety that must be met by manufacturers and integrators. Quite often, the general public isn't aware of those layers of protection and perhaps don't realize that BESS systems aren't analogous to, for example, e-bikes and scooters, which today aren't bound by the same sorts of rules. Nonetheless, safety remains a talking point, and rightly so. For the industry, many are also finding that best practices around safety is very much an evolving thing. And something that JinkoSolar is keen to emphasize is that that often means going beyond the basic requirements of standards and certifications. And JinkoSolar is not alone in this. At Energy Storage News, we have heard from other energy storage system integrators, which also see the need to go beyond the requirements of standards and certifications when it comes to establishing industry best practices on safety. In today's session, we'll be listening to short presentations from our speakers, and then I'll be moderating a panel discussion with our two guests. They are Neil Parkinson, Product and Business Development Manager in Europe for JinkoSolar's battery storage business, and Neil will lead the talks. And we're also joined by Jürgen Möllmann from Honeywell. Jürgen is Business Development Manager for Europe and can talk about some advances in battery safety tech and the best strategies for using them. Now, as always, interaction with you, the audience, is really important to us. So please do put your questions for the speakers in the questions tab that you'll see on the right-hand side of your screen. We'll have a few short minutes for a Q&A at the end. Now, we can't guarantee that we'll answer every question. In fact, we won't be able to answer every question, but we will do our best. And for all those that we don't get to, JinkoSolar will be more than happy to reach out to you offline after the session. Finally, today's session will be recorded and available to view on demand on the Energy Storage News website in a few days' time. So, with that preamble out of the way and without further ado, it's my great pleasure to hand you over to our first speaker, Neil Parkinson from JinkoSolar. Hi, Neil.
Hi there, Andy, and thanks for that great introduction. It's a great pleasure to be here, great pleasure to be speaking with you all, and thank you all for joining. So one of the questions that I get asked, or we get asked a lot recently, is why is JinkoSolar here to talk to us all about storage. And it's a very fair question. So as of February of 2023, so less than a year ago, JinkoSolar decided to jump into the storage arena. So everyone knows, or most people know, JinkoSolar for their PV credentials. So we are one of the, if not the largest, PV suppliers globally, present in 160 plus countries. So we have 54,000 staff globally. Over 8,000 of those staff are overseas, outside of China. We have 35 service centers in total, and again, a fair number of those are outside of China, which is unusual for a large Chinese company. Most notably, the recent addition of the UK service team to service initially the UK and Europe, and we'll be adding to that as well. So we jumped into the storage division, the storage sector, like I said, less than a year ago in February of last year, and we have really hit the ground running. We are effectively a newcomer to the storage industry. However, we have a large deployment already, mainly inside China, but also in the Middle East and different regions. We have the full scheme already of storage products. We have residential. We have a couple of flavors of C&I storage for commercial and industrial, and also we have quite a few variants of the utility scale storage systems. Our flagship utility scale storage is called SunTera. Just moving back slightly, the C&I product line is called the SunGiga. So the SunTera is the utility scale. Obviously, moving on the Giga to Tera in terms of size. So SunTera, quite simply, is a 1500 volt utility scale battery storage system. The energy content of our flagship SunTera at the moment is 3.44. We have a few different variants, and of course we are increasing the energy content of that to align with the global standards that are emerging. Up to, you'll have seen some of them are at 5 and possibly even beyond. So of course we, as one of the top players, are we're in that arena as well. Just very quickly, this is not a commercial discussion at all, but our very clearly stated goal and aim is that JinkoSolar, we currently enjoy 15% of the PV global market share, and the storage team, the storage division within Jinko, want to be mimicking that exactly in the storage arena as well. So we want a very large proportion of the business, and we believe that we already have a good track record to get that. So why do people integrate batteries onto the grid in the first place? A few reasons. Intermittency mitigation. The adoption of renewables is prohibited by nature itself, by the environmental impacts. We have, for example, the PV panels will not produce electricity when the sun doesn't shine and at night time. The wind generation is intermittent at best most of the time, so you can't guarantee when there will be energy being generated. The buffer that the battery provides mitigates that. Okay, so the battery stores the energy whenever there's an oversupply situation, and then that means you can discharge that energy back into the grid whenever there is intermittent supply. Some users like to use the battery simply for self-consumption, to reduce their energy bills, to reduce their electricity money that they have to spend. Other uses are for grid stabilization, for example, on frequency regulation to regulate the frequency of the grid itself and keep that stable. Very, very clearly, a lot of customers, and why would they do it if they're not going to, if it's not worth their while? Some customers of ours want to make money. So they only consider the commercial considerations, commercial implications of using batteries on the grid. They can trade with the energy, both charge and discharge, and they can make quite a lot of money. The user asset or the user owner, they can make a lot of money by trading at the right times. So barriers to adoption of the utility scale. There's questions from every customer about the commercial viability. So it's a question that we're very used to answering. We have we've got various models that we use, and we believe that we're certainly not going to be the cheapest. We never will be, never claim to be, never wanted to be, but we do offer a very good value for the money to spend. And this is not an inconsiderable amount of money that's going to be spent on these, but we believe that there is very good value. Now, we don't really care where we fit in the value chain as long as we're in the value chain. We can supply the entire system, or just the battery and the management systems. So other barriers that people come up with is they say it is complex. Yes, it is complex. It's not plug and play, but we have service teams, we have engineering teams that are very, very well tuned to bring your system online so that it's easy for you to understand, easy for you to use. One of the largest barriers to adoption that we see recently is safety concerns, and that's why we're here today to talk about these. So in terms of safety concerns, let me just start by saying that a safety concern in the lithium battery industry, if we get it wrong, if somebody else gets it wrong, if there's an electric car, for example, goes on fire, everyone publishes bad press. Oh, lithium batteries are terrible. Lithium batteries are not good. They're never going to be safe. They go on fire. Okay, so safety is an assumption. It has to be that when we're selling a system, it has to be assumed that it's safe, because if we get it wrong, if somebody else gets it wrong, then it hurts everyone in the industry, not just the battery suppliers, but everyone in the downstream supply chain as well. So we all get a bad reputation or a bad image from that. So to counter that, we go beyond the safety standards, just because, I mean, you need a basic minimal amount of certifications to be able to play in this arena, to be able to play in this game. So, but just because you get those certifications, just because you get that that piece of paper, that doesn't guarantee safety. What guarantees safety is the standards that you certify to and the methods that you employ when you're deploying the systems itself, when you're putting the systems together. So let's get it right. How do you build a safe battery? How do you build a battery in the first place? So honestly, there's not that many different ways you can build a battery. I tested this theory recently. I challenged my 15-year-old son as for one of his school projects to design a large battery, and he came up with something that was not too dissimilar to what you see from all of the main suppliers today, all the main OEMs. So to build a safe battery, you start at the beginning. You choose the correct components. The cell choice is paramount amongst that. We choose LFP because of its safety record, robustness. We put those cells into modules and racks. We control and monitor those cells using our battery management system. We fully integrate that into the cabinet along with the cooling system, along with the gas, the heat, the smoke detectors, the fire suppression systems, the ventilation, even in terms of the personnel safety. We have safety interlocks. We have MSDs, manual safety disconnects on the system itself. And if everything else does go wrong, if there's an event that's not foreseen, then it's a deflagration, which is simple terminology for explosion mitigation. So going a little bit deeper into the construction of the system as a whole. So we start with the cell. We've chosen LFP, lithium iron phosphate. It's one of the safest lithium chemistries that's on the market. We protect that. We monitor the cells at cell level, not just at cabinet level, but at cell level with our battery management system. If you can control, and we'll come to this later, but if you can control the three main parameters, you've got voltage, you've got current, and you've got temperature. If you can control those, and more so if you understand what the implications of those three parameters mean and how they're affecting each, they're each intrinsically linked to each other. So if you can understand the difference between and the implications of each of those and impacts of each of those on each other, then you've got a very good starting point to build your algorithms from. You can build your algorithms to monitor for lifetime and for safety as well. So if you understand those three, and we'll come to that a little bit later as well, then you've got a really good chance at making a safe battery system. In terms of how do we protect against unforeseen circumstances? Okay, so the way we put our modules together, and this is different. Modules are different in the PV side than they are on the battery side. A module is on the PV side is a solar panel. On a module that we see it's a group of batteries that are connected together. So we have one module. We have 4 modules inside each pack. So each module has 12 cells in series. Each pack has 4 of those modules inside it. The pack itself, so what we call the pack of the module, is the core of the battery system itself. That's what we have to keep cool. That's what we have to manage environmentally. So we have a very advanced liquid cooling system. It's a water glycol mix, 60%, 40% in the cooling. That's controlled by an onboard chiller, fully integrated chiller. Within the pack itself, we also have electrical isolation. We have manual service disconnects, and we also have multi versions of the anti-leak system. A lot of people ask me the question, or ask us the question, why do batteries go on fire in the first place? A large proportion of the recent fires that you'll have seen, and there's been some very high-profile ones, we'll not go into them now. We can do that later if you wish. But a large proportion of the fires is caused nothing to do with the battery itself, nothing to do with the cells. It's to do with the leakage of liquid onto the bus bars. Okay, so something as simple as a fault that causes a leak. Water and electricity don't mix very well. They don't make very good partners. So the system is really designed that it will detect leaks. We don't have to do that in terms of the certifications, but it's something that we see as being necessary to do to give extra assurance and extra comfort to the user. We take those packs, we put them into 8 in a stack. We call that a rack, and we take those racks and we put them into the system. The system is integrated fully. It's in a 20-foot container. It's an industry standard container, which keeps the costs under control. There's nothing customized about that. We have the ability, because it's effectively a Lego block, if you want to call it that, system. So what we've actually done is we've standardized the pack and module design. We've taken the same cells, we make the same module. So the same module fits into all of our products, CNI and utility, which means that we can benefit from the scalability of that. So in terms of the system, fully integrated gas, smoke and heat detection systems, we've got fire suppression systems, If everything else goes wrong, we've got active ventilation, and we have explosion-proof deflagration systems, and also something that is not very common. We also have separation at all levels within the system. We separate the areas and we call them fireboxes. Okay, so if something was to go wrong, if something was to go awry, if there was a faulty cell, or if a forklift was to drive through the side of your container and set the fire, let's face it, you can make anything burn, you can make anything explode if you try hard enough. So we want to mitigate that by having separation, which means that you cannot, or it's extremely unlikely that you would see a fire outside of a specific area. Inside the pack itself, we have intumescent material coating the inside of the pack, which means that you have a 1300 degrees protection for a period of time. We can have that up to 1 hour. Typically, it's 30 minutes at the pack level, and at the container level, we've got 1 hour of fire protection. So in terms of the fire and explosion proof, the deflagration that we talked about earlier, the insulation begins at the cell level. So we protect against heat transfer between cells to mitigate against thermal runaway within the pack itself. We use very commonly used technology, mica sheets, very high temperature sheets. Between the cells, we have electronics at the module level. We have electronics at the cell level. We have there's the 30-minute heat resistance coating on the inside of the module itself. That provides up to 1300 degrees Celsius, which prevents propagation of any what we call a thermal event, an exothermal event from the cells. That stops that propagating outside, and it's the propagation of those of any exothermal event that we look to prevent when we do all of these certifications. Your 9540A, your IEC 62619, there's different variants of those in different countries as well. So we look to mitigate against the propagation of heat and of fire flames. So if all else goes wrong or fail safe, we have both active and passive measures in terms of the venting. Venting will be triggered by our gas detection and by our fire detection systems. There are internal barriers, like we said before, to control that spread. But if we decrease the concentration of any combustible gases that are built up there, hydrogen or any of the other combustible gases that can be present either after or during an event, an exothermal event, then we want to expel those into the free air. If you can keep that level to below a certain percentage, and we can go into that in detail if you wish, but keep that below a certain level, then that means that you cannot have a fire or an explosion just simply by controlling the concentration of the gases. And I know that Jürgen, their technology is brilliant in terms of what it can do and what it can detect, and basically how it triggers our equipment, our battery management systems, our mitigation systems to avoid any situations becoming nasty. As a fail-safe, as a last-ditch mitigation, what we do is we have a dry pipe. So if the sprinkler fails, if the sprinkler doesn't work, if the other fire suppression, the aerosol fire suppression doesn't control the fire, we have the option to add to flood the system, to flood the battery completely. It's a well-proven, tried and tested method, and it will keep the battery safe. So we don't have to do that. Other companies do not have to do that, battery suppliers, but we choose to do that. We've listened to lots of people in the industry, including insurance companies, including the fire and rescue, and simply by doing that means that if you can control the probability of a fire or an explosion event being present outside of your container, then that's where you want to be. In terms of the battery management itself, and I think this is the last slide. So the earlier we can detect any issues, the better. So we use multiple different sensors, multiple different techniques. We link those to our battery management system. And to me, battery management system has to be an intelligent, it's got to be an intelligent way of looking at the entire battery system, not just at the cells, but the systems and how the packs and the containers interact with each other and with other components within your site. So we have a deep understanding of the battery itself, a deep understanding of the control systems that are implemented as a whole to keep the battery safe. So with that, I would like to hand over then, possibly hand back to Andy and then across to Jürgen.
Thanks, Neil. Oh, actually, not a lot for me to say, except that we've got lots of great questions coming in from the audience. Please keep those coming. It makes my job more difficult, obviously, because I've got to sort through the questions and see which ones to ask. But at the same time, it makes my job even more exciting. So please do continue with that, and we'll see how many of those we can get through in a quick fire at the end. So yeah, with that, moving on, Jürgen, love to hand over to yourself.
Thank you very much, Andy, and thank you, Neil, for your presentation. My name is Jürgen Möllmann. I am Business Development Manager at Honeywell Fire in Europe. Most of you might heard about Honeywell as a fire safety company with fire panels and smoke and heat detection, aspiration smoke detection. Extralis, for example, the Western unit is part of Honeywell. So my focus within business development is on renewable energy, including battery storage equipment. So why lithium-ion battery safety matters? So the EPRI website tracks all the major events that are available in the media. And in the last 12 months, there are around 10 storage failure events listed, and also some others for warehouses. So I think it is good to understand things happen. As Neil mentioned before, it will harm everyone in the industry. So every battery storage that gets a failure event and is in the media doesn't help the industry, and we need the battery storage in the future to be more sustainable. So why lithium-ion battery safety matters again? So safety is mandatory when a risk for environment and health is identified. And by nature, lithium-ion technology has a flammable and toxic risk. So looking at fire scenarios, and they are much different than from oil and gas, from other industry we know. So the propagation between the cells and therefore the duration of a fire and the difficulties to suppress or extinguish the fire give us a lot of more challenges for this safety risk. So therefore, we have different requirements for the risk prevention and mitigation on batteries, as Neil already mentioned in his presentation. So we all need to understand there is a risk. There is, on one side, the internal risk, as Neil mentioned, the cell quality is really important. But then you also have external risk, and this is mainly handled by or hopefully handled by the battery management system. So the quality of the cell and the battery management system is really important. If something fails here, we have a temperature increase as a result of this failure, and this can also result in a thermal runaway. We at Honeywell looked at it and said, okay, can we somehow detect at the point of this temperature increase before a thermal runaway? So if we cannot control it and stop it, then we have the exothermic reaction and the off-gassing of explosive and toxic gases that can result in a potential fire. So how can sensing technology increase safety? So usually you have this interesting, nice triangle. So you have the abuse, either electrical, thermal, or mechanical abuse. This will first go into the initial cell venting. And the initial cell venting is electrolyte solvent vapor. If you cannot detect at this point this cell venting, it will go straight into thermal runaway. When the cell is going into thermal runaway, the propagation to surrounding cells will cause abuse to the other cells. They're starting cell venting, going into thermal runaway, and this is why we have this endless triangle on a battery cell, and this makes life more difficult to detect and prevent it. So therefore, we should look at new technologies. New gas sensing technologies provide reliable cell venting detection. And to understand that this is gas detection, it's not fire detection. So we want to prevent the thermal runaway and therefore fires. So, and this is a common process for decades in the oil and gas industry, for example, where we have high hazards as well, similar to batteries, but in a different scenario. So we should open our mind, look what other industries can do from the technology point of view and implement it also here on batteries. So again, the different stages we see that the battery abuse of gas, and if we have smoke detection and smoke coming off the cell, that's most likely the thermal runaway, and then this can cause a fire. So why is the line timer, that's the name of the product we have in our portfolio, is able to detect as early as we see here? It's looking at the cell venting, and this is around half of the composition of the electrolyte solvent vapor. During the stage up to the thermal runaway, it decreases the concentration and the components out of it increasing. And this is a reason why the common technology only detects close to the point of the thermal runaway. The line timer is specially designed for detecting electrolyte solvent vapor, so a much earlier stage. And to give you an understanding, what we have here is for a certain cell, it's about 45% electrolyte solvent vapor at the first cell venting and low concentration of all others. At the point of the thermal runaway, it's a lower concentration, about 5%, and other concentrations when a higher percentage. This percentage is not for every lithium-ion battery cell the same, but we tested all technologies from lithium-ion batteries and battery cells. The concentration varies a little bit depending on the cell, but the picture at the end of the day looks the same. So now we have a comparison here related to the other technologies. So as you see here, the green dotted line, that's the line timer response, which is approximately 13 minutes before thermal runaway, which is the red dotted line when we have the temperature increase during the thermal runaway. So aspiration smoke detection, as you can see here, that's the blue line and orange line detecting only closer to the thermal runaway. We have done other tests where it's together with the temperature increase of the thermal runaway or even after the point of the thermal runaway. The same for gas detection. You see here the CO, H2 and CO2 detection and the methane CH4 detection. Pretty much the same picture. You see it somewhere around the thermal runaway, and the line timer can detect approximately 30 minutes before. This approximately 13 minutes is based on our test we did. So depending on the test setup, you can see on the right upper corner, it was an open space test, 2.1 meter above the cell we tested it with a LFP cell, prismatic, and the abuse was overcharging. So we did also other tests like over temperature. We used different cell chemistry, different form factors, and therefore we have a variation in this golden time. And this is between 5 and 25 minutes. And we use for our presentation here the 13 minutes as an average time to prevent the thermal runaway. So going the next step forward, so the early warning is basically also using the UL 9548 test method. And here you see as well temperature increase by external heating, and several minutes before the thermal runaway, the off-gas detection can detect the first electrolyte solvent vapor. So barrier to thermal runaway. So at the point we did in all our tests, we first of all looked at what is the time before the thermal runaway, and let the cell go into thermal runaway. Then we repeated the complete test again and switched off the abuse. So took away the external heat or just switch off charging at the point of the off-gas detection. And in more than 95% of all our tests, we could successfully prevent the thermal runaway when the abuse factor could be isolated. So preventive action, this is part of the FBA need to know guide. This is also talking about electrolyte solvent vapor detection. So you have the different levels of your safety methods you implement in the battery safety. So if you have abuse, most likely the BMS should control it and get everything in a safe state. If not, the electrolyte solvent vapor detection can help the BMS system to react the right way to avoid thermal runaways. If not, then you have an explosion and a fire risk, and then the next steps to mitigate the event. So again, preventive region, as Neil mentioned before in his presentation, so cell quality is the first and important consideration on prevention, then the battery management system. And the line timer, in our point of view, is the first external safety system for battery storage systems. When it comes to smoke detection, gas detection, it's already too late. We are already in a thermal runaway. So typical of installation for a battery storage system, like a container, is, as you see here, the black dots are the monitoring sensors on top of the battery rack. Depending on the rack design, is either one sensor per 2 racks or one sensor per rack. There's a communication daisy chain, including here reference sensor. Reference sensor is used to avoid false positives by background gas coming through the door or from the HVAC system. Then we have some control equipment here. In this case, we have two daisy chain systems for two different fire zones. And the maximum design size is up to 100 sensors. So you can have multiple installations and multiple containers at the site on one controller. This year, we will also have another controller with up to 500 sensors. Third-party report and guidance. I just mentioned the FBA need to know guide RE1, battery energy storage systems. They also, risk control recommendation is looking at electrolyte vapor detection. DNV Global did a test in 2020, and they also mentioned the line timer as the only technology that can detect the off-gas event. Also, FM Global mentioned early invention thermal runaway prevention, and this is from the revision July 2023, where they added the off-gas detection as a preferred solution for detecting the electrolyte and prevent the thermal runaway. As I mentioned before, Honeywell is not only looking at this line timer product, we have a complete line of equipment, and we have this ultimate guide for fire and gas safety and battery energy storage. So we look at the different steps like preventing thermal runaway. Still, for fire codes, you need sometimes detection, Also, if there is a cable fire or other equipment, you still need fire detection. Therefore, we also have really fast detection. In this case, here is the Vesta aspiration smoke detection system. And then we have a control panel, fire panel, different brands depending on the area where you are and which regulations. And finally, we have this connected cloud service, which can give you on your mobile the exact status of your fire system and safety system inside the container before you open the door. And from our point of view, it's not designed for a container, it's designed for a building, but we can use it here as well to increase safety for people. So how does the business case look like with fire safety? From our point of view, first of all, it's the asset availability. Detecting an off-gas event and preventing a thermal runaway will give you maybe a downtime of a week, 2 or 3. If you have a fire and the container burns down, the replacement takes easily a year. So you have around roughly 50 weeks more asset availability by preventing thermal runaways. And I think that's a good business case. Another important point here is the restoration and insurance cost. So we're also talking to insurance company, and the insurance company are looking now what they can do to reduce the risk and to reduce the insurance costs. And then finally, as Neil mentioned at the beginning of his presentation, the public perception. And this is really important because this hurts the entire industry. Lesson learned quickly, heat and gas generation, the electrolyte salt and vapor off-gas event. During the thermal runaway, we have this flammable gas release, but also toxic gas release. From my point of view, that's a little bit more difficult and more dangerous because you cannot see it. The fire you can see and everyone will run away. On the toxic side, toxic gas detection is or gas hazard is more difficult. So therefore, we are looking at different layer of protection. There is not only one solution for battery safety. As I said before, by nature, there is a risk and we have to work with this and reduce the risk as much as we can. So therefore, going back to the oil and gas industry, it's common to have a risk assessment and risk mitigation by looking at different layer of protection. In this case, again, battery quality, battery management system, data analytics, early off-gas detection, early smoke detection, and suppression if we still have a fire, either from a battery or from other sources like cables. Finally, the Line Tamer won last year 2 awards. One is a DCD award and the other one is the highly recommended product of the year by Energy Storage. So with this, I would like to thank you for listening and giving back to Andy.
Excellent. Thank you so much, Jürgen. Yes, and as the Energy Storage Awards hosted by our publisher Solar Media, we're very, very happy to commend the great work of Lion Tamer and of course all the other great companies in the industry. But yeah, congratulations on that, Jürgen, and to your team. So yeah, lots of questions in from the audience. Great level of enthusiasm and engagement. As mentioned, we will only have time for a few of those audience questions. So JinkoSolar and I guess Honeywell would be more than happy to continue those more detailed discussions and reply to your questions offline, but we will get to some of those shortly. Before we get to that, a few questions from me, I think. So Neil, hi again.
Hey.
Talking about the context of battery lifespan, so a little bit off from the subject of safety, but obviously very closely associated. So in the context of battery lifespan, how does JinkoSolar approach that issue and ensure sustained value for customers? And I wonder if there are specific strategies or technologies that can contribute to prolonged battery life.
Okay, so that's a great question, Andy. Thank you. Well, it's a great question. It's a very long answer. So I mean, we can go into as much detail as we want with anyone who's interested in it, but the basics of it are that it starts at the life cycle of the battery starts with the cell, obviously. So inside the cell, we use prismatic LFP cells. Inside the cell, a lot of it comes down to cell construction itself. So inside each cell, there's a lot of real estate. Yes, you can maximize the energy density within the cell, but you can also optimize basically the layout inside. Remember that these cells in our industry, in our space, are optimized for energy, not power, which means that you don't have to have massive current collectors. You don't have to have huge current carrying capability. Remember, these are 0.5 C or 0.5 P rated, which is a 2-hour cell typically. So that would be the maximum sort of currents that you'll be seeing. Therefore, you can minimize the amount of cell welds, for example, at the current collectors and at the different junctures. So it really comes down to how you construct the cell itself. And that's talking about the cell, talking about the battery management, how we actually manage the cell. Once, like we said earlier on, if you know and understand the intrinsic links between the main parameters, your voltage, your current, and your temperature, you understand the links between those, then you can optimize the lifetime. You can optimize how how the battery is used, how the energy is implemented from the cell to the user. Operating the battery, for example, at the high and low state of charge, high and low SOC, you're entering into a higher state of impedance on both of those states. So you want to minimize the duration that you're either charging or discharging in those portions. So yes, you can charge and you can discharge in both of those portions, absolutely no problem. But you want to use your battery management algorithms, your battery management strategies to minimize that. You don't want to do it as a standard every time. And certainly you may want to limit the amount of time you're in those high impedance areas. And keep the battery within its safe zone, within its not safe zone, within its comfort zone. Let's put it like that, where it's going to be seeing minimal degradation because of the usage itself. Not sure if that fully answers the question, but if anyone wants further details on that, more than happy to have a very detailed discussion if you wish.
That was excellent, Neil. I mean, I think to fully answer the question, it would be a whole webinar in itself. And I appreciate there's a lot of different factors in there, but I think you gave a very good overview. So yeah, I'm sure our audience appreciated that. Talking about specific components, so there's a few questions in here about various components in those layers of protection that we were talking about within the battery storage system. But also, I would say within that, the most questions we got, unscientifically speaking, I think, I haven't actually done the stats on this, but I think the most questions we got were around the BMS battery management system. So, and you did mention that within the BMS itself, there are multiple levels of protection. But yeah, what role does the BMS play in enhancing the safety profile of battery storage systems? I guess with regard to the JinkoSolar equipment, but also just more generally in terms of the principles, I guess, within that.
Okay, so the principle of the battery management system itself is it's quite simple, really. It's to manage the battery system. All right, so you have multiple levels of control, of monitoring. If you have the ability to understand what your battery is doing, what your battery is feeling, what your battery is seeing at any particular point in time, then you can control its response to that. If the battery, for example, is being overcharged or over discharged in terms of if something has failed inside, then the response will be an increase. Let's take overcharging as the example. You overcharge a battery, you will increase the voltage within the cell, you will increase the temperature within the cell. Like I said before, at the high impedance points of the SOC curve, you will have an increased temperature rate as you continue to charge. as you continue to charge, your cell will increase in voltage, and that's what I mean about the intrinsic links between those three parameters. So you can seek to lower the current, you can seek to lower the voltage, you can have all of those areas that you want to control, that you want to control to what you want them to do, what is best for the battery system. So as you have taken each of those parameters, you monitor for excursions outside the safety area. Okay, so inside the battery management system, there's a couple of different levels of user configurability or of manufacturer configurability. So we have safety levels set under which no circumstance can change those systems, because to do so would be putting the battery in an unsafe position. By unsafe, what do I mean by that? I mean either it is unsafe in terms of the degradation that the battery would experience if it was continually operated outside those areas, or it could potentially enter a high-risk area in terms of overcharging. Now, luckily, because we have, not luckily, by design, we have taken the decision to only use LFP. I've seen and been party to multiple different test regimes, test routines with the likes of TUV and with the likes of DNV for different industries, even before my time with Jinko. So I've seen the tests being done, and believe me, LFP, it is the most, it's certainly one of the most safe lithium chemistries that are available. There are, like I said, you cannot mitigate against risk. Okay, what I mean by that is risk is about what can happen. You can never eliminate completely risk, but what we can do is we can mitigate that risk. And that's what we do with the battery management system. We control the battery system. Anything that's outside of parameter, you inform the system. You inform that by using sensors, and that's where the line tamer comes in. The line tamer would be informed by our battery management system, or vice versa. The line tamer informs the battery management system that it has detected a problem. Jürgen mentioned about the 30-minute system, 30-minute sort of time frame that you would have of a warning of an event coming up. We can be informed of that, and the battery management system can take action. We have the facility built in that we have redundancy, so we can both limit the current in any portion of the battery. Like we have multiple different racks. We can even take it down to completely cutting off, activating the contactors for particular racks, so we can eliminate any current going through that, therefore eliminate the risk that has been detected by the line tamer well before it could ever start to cause an actual safety issue.
Excellent, excellent, thanks. Yeah, no, definitely. And speaking of line tamer, Jürgen, you did mention sort of gaps in education around battery storage and the
yes.
Yeah, sorry, I just have a bit of a delay in my video here. I don't know if you're experiencing that as well. Apologies for that. But Jürgen, you did mention gaps in education. So where is the knowledge lacking at the moment? And I guess secondary to that, what might be the industry's role? But yeah, let's start off with the piece of where the educational gaps kind of need to be filled.
Yeah, so what we see is that in the battery industry, it's a relative new industry, relative new market, and therefore there are no code and standards really applying to fire safety, for example. And this is where we have to look at different technologies, new technologies, to get approvals for new technology like a line tamer takes many years. So we have to look right now at what is available in the market, what is the best known technology, and how can it help. So therefore, it's not really important to look on a standard regulation for fire safety, for battery safety. It's also looking at the technology that is available, doing a risk assessment, and then adding the different layer to mitigate the risk. So, and therefore, for example, the line timer, it can detect the electrolyte off-gassing. The electrolyte by nature is pretty common in all kind of different battery cells for lithium-ion batteries. So therefore, the line timer can detect the off-gassing of every lithium-ion battery gas release and off-gassing. And so it works for all kind of technologies within the line lithium-ion battery. I hope this answers your question.
It did answer the question. I'll forgive you the little plug there for the line tamer technology, but of course it is something that a lot of people in the industry are talking about. But yeah, Neil, Jürgen mentioned there about the standards and certifications, and I think there's, well, I'll let you explain it and answer the question, I suppose. What are the key industry standards and certifications that JinkoSolar adheres to? And secondary, I think we mentioned the need to go beyond some of those, the standards, I guess. And so how does JinkoSolar go beyond certification to get the best levels of safety for all levels of battery storage systems?
Sure. Okay, so like I said before, to play in this arena, you have to, you got to comply with the minimum standards. Okay, so, and anyone can play in this arena if they comply with the minimum standards. Okay, so the likes of the IEC, the European 62619, the fire propagation testing and stuff like that. You've got the European 50549-1 IEC certifications that's complied with. You've got your 63503, believe it is, and also you've got your standard UM38.3 for transportation. So no point in building it if you can't transport it. We've talked about the 9540A, the UL, specifically for the US or designed for the US. You've got the UL 1973 certifications, all safety related standards, all geared towards making sure that the cell is capable or the system is capable of withstanding a safety or security related incident or accident. It goes beyond safety standards though. Okay, like I said, that's the minimum requirement to play in the game. Okay, so it's about how you implement those standards. It's about how you build your system. It's about applying best practice. It's about implementing functional safety within your battery management system. All of those things come into it, some of which are not necessary to comply with so that you can actually play in this arena. But we in Jinko, obviously, we take the we take it very seriously because we've got a name to protect, we've got a reputation to protect, and definitely on the PV side, we wouldn't want to be having any safety related issues that were raised because we haven't done something, or that we could have done something quite easily but didn't. The likes of the factory acceptance tests, the likes of the site acceptance tests. In quite a lot of cases, and I watched one of your previous webinars on this exact subject, and that's the thing about these webinars. That's what I love about them. Even if you don't learn anything that's brand new, you'll always pick up something that is a small snippet of information. So what I picked up from that one was that the site acceptance test and the factory acceptance tests, even if your factory acceptance tests are 100% and everything passes, when you get to the site, there are, in some cases, there are up to between 20 and 25% of the site acceptance test shows up an issue that wasn't captured at the factory acceptance test. That's why Jinko makes sure that we spend an enormous amount of time and energy and resource to make sure that aspect is done. So it's about implementing the certification. It's about making sure that certification is geared towards the right direction, It's about ensuring that what you have done within the battery itself, within the construction of the battery, and the deployment on site, the implementation on the customer site has been done correctly, making sure that the likes of the anti-leak detection systems have been implemented correctly. That was a lot of the systems, and I know I'm going on is probably answering more than your question needed to, but in terms of detecting issues that can cause safety concerns, even if it doesn't cause a safety event, if it causes a safety concern, then that's something that we want to address at the earliest possible moment. And the last point at which we can implement that in terms of physical intervention would be at the site acceptance test. So we do that on every single container, on every single system that goes out there. That is done to a very high level, certainly in Jinko. And Jürgen and I were we were giving a presentation in Brussels together, actually, and both of us called for the European Parliament to implement more rigorous safety inspection testing. We're not calling for it to be global. We're not calling for it to be restrictive in terms of what we can and can't do, but we need the industry as a whole, because it affects everyone in the industry. So we want the industry, the battery industry, to comply with more rigorous testing regimes than they currently do. Because yes, you've got that piece of paper, you've got that certification. Does that make you safe? Does that guarantee safety? No, it doesn't. You can never guarantee safety with a certification. It's about how you implement that certification.
That's great. That's a great answer, Neil. Thanks very much. And yeah, I think an important call to action within that as well. And Jürgen, I guess something that you share in terms of sentiment, but yeah, I just wonder if you have any sort of further perspectives, kind of as a technology provider, but not a system integrator, into this, in terms of what you think we should be seeing in terms of standards, certifications, best practices, and the industry approach to adopting them, I suppose.
Yeah, so my comment on this, I fully agree with what Neil said, and from the technology provider for safety system, we also focus, and that was one of the comments in Brussels when we were on the stage. We were asking for faster response to new technologies, and then it's much easier to implement that in the system. So if we have a new market like battery energy storage, we also have new technologies to protect it, and not only on the fire safety system, as Neil mentioned before. BMS systems also not really regulated, but there should be a standard to that customers understand what is the best safety they can get.
Yeah, absolutely, absolutely, folks. So in the interest of time, I think we should open up and start asking a couple of these audience questions. And we'll just see how many of them we get to, because I think so many people asked a lot of good questions. So let's just see. I hope no one has a hard stop in the next couple of minutes, but I'm aware that most of the audience is still able to be with us. So let's do that for them. So Mandar from the audience asked, thank you very much for your question, Mandar. Where the manufacturing and assembly of components and container preparation takes place for JinkoSolar. And I guess, Neil, if there's anything to add in terms of Jinko's strategy towards manufacturing as well that we haven't really covered yet.
Sure. So 100% of our utility scale battery systems are assembled in our state-of-the-art factory in Haining, which is just southwest of Shanghai. So we recently have returned from the factory visits. So I would challenge anyone to go out, to contact us, and we will we'll personally take you out there, and we will give you the tour of the factories. It is mind-blowing. The implementation of the construction, not just of batteries, but of every component that goes into the system. Everything has been considered. Everything has been implemented in a cost-effective, yes, but in a method that is easy to control in terms of manufacturability, and in terms of safety. So every decision that is made has to have it's got to meet certain criteria. Is it safe? Is it affordable? Does it make the system better? Does it deliver value to the customer? So I would challenge anyone, and I will stand over that. I've been there. I've seen that. And and I've seen a lot of manufacturing plants, believe me, and this is impressive. Okay, so I would challenge anyone to go out there and find fault.
Excellent. And on a somewhat related note, I guess, Gerald asked the question. Thanks for your question, Gerald. Which cell suppliers JinkoSolar is using? Because I believe, as they quoted your words back to you, cell is the most important component, Neil.
Okay, thanks for the question, Gerald. So I would rather not, in public open forum, go into the exact cell manufacturers that we do use. I'll be happy to have that conversation directly with you, Gerald. No problem at all. But we use only selected tier 1 manufacturers. We're certified. Once we get into discussions about systems, absolutely no problem. In fact, you will see on the certifications which cell manufacturer would be used in your system. You would have the choice as a user, as a site, about which system or which cell manufacturers you want to use. If you have a preferential cell manufacturer, then we can look at that. If they're not already ones that we currently work with, then we can take a view on it. But something that we haven't widely advertised as a Jinko will be a cell OEM in our own right. So as of the end of Q1 this year, we will be releasing our first revision of prismatic LFP cell, and we'll be more than happy to go into that, not just with Gerald, but with any other customers that would be interested in having that conversation. In fact, that's a discussion that we can have. It's the intention is to have a specific webinar for cell manufacture and for cell performance characteristics. So more than happy to have that conversation. So takeaway message is we use tier 1 OEMs where necessary, and Jinko will be one of those tier 1 OEM cell manufacturers in the very near future as well.
Excellent. That's really exciting to hear, Neil. Have you just given us an exclusive there, or is that a piece of news?
No. It's not secret. It's not secret.
Okay. Well, it's still exciting. Let me put it that way. Okay, great. So going into a slightly more technical question. So Liam Anderson asked, so you mentioned leaking electrolyte onto bus bars as a leading cause of fires with water and electricity don't mix well, I think, with some of the words used. How does this align to the water suppression dry riser system, which will put water into the unit and onto batteries?
Okay, that is a very good question, very astute question. The answer to that is whenever there is a leak coming from the coolant system, and that's primarily what we're talking about there, what I was mentioning in the anti-leak detection systems. So when you have a leak that is coming from the cooling system, what you're talking about is you're having a small amount of water, perhaps dripping or perhaps dribbling onto your bus bars, and that can cause an arc, that can cause sparks. Because it's a small amount of water, you get the same impact if you were to spray and make your bus bars wet by any method. So you don't want a small amount of water to be, liquid to be present in those high current areas. The difference between that and the dry riser is that you completely flood the area. In terms of you cannot have oxygen that is present in the presence of that spark and of that arc, and therefore you do eliminate the risk of fire when you do that. And I say, and I use that word advisedly, you eliminate the risk, whereas before it said you can never eliminate all risk. If you completely flood the area, if you completely flood that system and that risk area, then you do eliminate the fire risk from that particular stimulus. I hope that answers the question anyway.
No, yeah, I think it does. I mean, I dare say there's probably, you know, a lengthy, a detailed discussion you could go into one-on-one with the person who asked the question. But I think for now, that's a really more than satisfactory.
It is a proven, it is a proven way. There's been a lot of testing done, and this goes back 10, 15 years. I can remember doing tests in the marine industry. And in the railway industry, where you have systems that completely flood the lithium battery system. You can do it with salt water, you can do it with fresh water. Doesn't matter. The marine industry is an extremely difficult area in which to get certification, and that is one of their go-to or fallback methods of making safe a battery event.
Sure. Thanks, Neil. And so that, well, I was going to say so that Jürgen doesn't feel left out of the questions, because there's quite a lot of questions for you as well, Jürgen, in this. And so one, I'm afraid I don't have the audience member's name handy, but I do have your question, so apologies for that. Jürgen, how reliable is the Lion Tamer in avoiding false positive detection? So, for example, gases that are normally present in the installation at ambient levels?
So yeah, good question, and therefore we have this reference sensor to avoid false positives. But on the other side, the logic behind the smart sensor is also avoiding false positives by light background gas. So the line timer sensitivity is 1 ppm per second, and it's not looking at a ppm level for high sensitivity, but it's also looking at a ramp of rise of the gas signal, which is typical for off-gas event.
Sure. Okay, and I think there's there's a few like much more detailed questions I think for you in there, Jürgen. So I'm sure JinkoSolar can share those with you, but I genuinely don't think you could probably get them answered in the limited time we have. But we'll see if we have a minute or two. Neil, one thing I quite wanted to ask that I guess is yeah, maybe a fairly obvious question, but no one else has asked it yet. So I'm glad that our audience member did. So the audience member's question was, if JinkoSolar focuses on solar plus storage installations, or also provides standalone energy storage systems. But I think by extension, the logical question from there would be kind of what are the different safety considerations, if it's fair to ask that. Don't let me put words in your mouth, but yeah, how do you see that? Is JinkoSolar going to focus, as I might guess they would, on solar plus storage as well? How's that going to work, and how do you kind of view those differently in terms of the safety profiles, if at all?
Okay, so yeah, thank you for that. It is a core requirement that the JinkoSolar system, or the Jinko battery system, is compatible with multiple different topologies in terms of connection. So we have the capability to be grid connected, standalone, and co-located with multiple different generation sources: PV, wind, hydro, all of those. So we have the capability. We are an energy buffer. We are an energy block in which to store and discharge energy. So in terms of how we locate that energy, it's basically done in terms of the utility storage. It's done as a block. So it doesn't really matter what is feeding or what we're feeding into from that. So we have the capability to do all of the above: co-located, grid storage, standalone, grid connected, all of that. That's all well within the capabilities, all within the understood parameters of what we already have. So what was the other point of that question, or was the other part of that question?
Oh, so in terms of whether that, whether there's key differences in your thinking around safety for those different types of
not really, except in terms of the spacing, in terms of the separation between, for example, the PV panels, the PV modules. You would have to have a separation between the battery and the PV generation side. So, but in terms of the safety of the system itself, no, it's pretty much the same. Because you've got energy coming in, you've got energy going out, and it doesn't really matter where that energy is coming from or going to, as long as it's controlled within the parameters that are set for that site.
Excellent, excellent. Well, thank you very much. So, everybody, I think we've come to the end of our allotted time for today. Unfortunately, because I think there are lots more questions great questions that have come in, and as I say, I'm sure you will enjoy continuing those conversations offline after this session's finished.
Be more than happy to do that, Andy. Yep, be more than happy to do that and come back to as many of those as we can get to. If anyone feels that they have a question that they really want to ask or really need answered, then feel free to reach out. I think, Andy, you have the contact details available for us, so we'll be more than happy to take those questions and answer them offline.
Excellent, excellent. Thank you very much, Neil. Okay, so with all of that, just want to thank our speakers. Thank you so much for joining us, Jürgen.
It was a pleasure. Thank you.
And thank you, of course, to you, Neil, and to JinkoSolar.
No problems whatsoever. Thank you. Appreciate it.
Excellent. Goodbye, everybody, and we hope to see you all next time. Thank you so much for joining us.
Thanks, everyone.
Thanks, everyone. Bye-bye.